After cloning a remote, what is the next step in the Git collaborative workflow? Push a branch up to remote, delete your clone, reset to previous commit, fetch from the remote, merge in the local master branch. That one. What piece is missing from the command below? Git push origin, or the name of the collaborator you're working with. Sorry, the name of the branch you wish to push up to the remote. Which is true about the command below. Git clone remote location, clone name. This clone will not be connected to the remote. None of these. The clone automatically deletes the remote. The command clones a Git project. What is a remote? A Git repository that allows multiple collaborators to work on the same Git project. That's it. The output below is typical of which command? Origin, fetch, origin, push, git remote, dash verbose. Command git fetch does what? Fetches new commits from the remote, but does not merge them. Yeah. Which command merges the remote origin into local master branch? Git push, git merge, origin master, / master. Yeah, let's go. Deploying to GitHub pages. GitHub pages is actually similar to Vercel. You can deploy your applications through Vercel, GitHub pages. There are many Firebase. There are many deployment methods. So start next project, off-platform project excursion. Give me 2 seconds. Excursion. Okay, intro into best practices for GitHub. In the next few interactive articles and projects, you'll learn the following skills that level up your GitHub use. How to create and write a pull request that is well formatted and easily reviewable by your team. Learn about Git Rebase and practice using it, which can help clean up your team's commit and merge history. Manage a GitHub repository by setting which users have which permissions and setting default behavior on branches or pull requests. Use git config files like .gitignore to make the code in your repository more organized. Let's dive in. How to write a good pull request. What is a pull request? What is a pull request? Sonia, a new member of Codecademy's engineering team, has just finished a snazzy navigation menu on a branch titled Sonia Feature Navigation menu. Her changes will not be merged to the main branch until a request is approved. A pull request is a feature of GitHub and other source code management tools to review code before merging it from one branch to another, usually the main branch. When Sonia creates a new pull request, her repository will automatically be set as the source repository, and the project's repository will be set as the destination repository. She will get the option to specify the source branch and the destination branch. She will be greeted with a preview of the changes between the two code bases. And whether the branches can be merged automatically depending on code conflicts. In the pull request description field, Sonia must describe the code changes and what features this merge will add to the main branch. So Sonia's proposed changes can then be accepted or rejected by her teammates. Each pull request has its own discussion forum, creating a place for collaborators to leave feedback. They will review Sonia's code, suggest what should be removed or changed, and how a code can be simplified or improved. Any further commits Sonia makes to the source branch will automatically be reflected in the pull request. Once her changes are accepted by the project's collaborators, a branch can be merged into the repository's main branch. GitHub will keep this pull request in history as a record of the code change, Sonia's contribution, and the discussion that took place. This pull request process is not only a way to increase group knowledge or improve product quality, but also an exceptional way to develop professional skills through group critique. Next, we'll discuss how to write good pull requests. Fill in the code. Complete the sentence below. Pull requests allow for collaborator review and unproposed code changes. Review and feedback before code changes. On proposed code changes before they are on the branch. Before they are merged on the local branch. Okay, so how to use Git Rebase. When working with Git Repository, there will be a time when we need to combine changes from a working branch into another one. This can be accomplished with the use of commands, merge or rebase. In this article, we'll focus on rebase and see how it can work some magic in order to manage the future development of a product by simplifying a Git history. What is the Git rebase? At a high level, rebasing can be understood as moving the base of a branch onto a different position. Think of it like a redo. I'm meant to start here. Consider that a team just completed the production release while working on a completely new feature branch called New Feature. A co-worker finds a bug in the production release main branch. In order to fix this, a team member creates a quick fix branch. squashes the bug and merges their code into the main branch. At this point, the main branch and the new feature branch have diverged, and they each have different commit history. We can visualize this in the image below. If we want to bring the updated changes from the main to a new feature, one could use the merge command, but with rebase we can keep the git commit history clean and easy to follow. By rebasing the new feature branch onto the main one, we move all the changes made from the new feature to the front of main and incorporate the new commits by rewriting its history. We can see how this is done below. After rebase, you can see above that the new base of our new feature branch is updated. Main branch with the previous changes from the bug fix implemented. One of the major benefits of using Git Rebase is that it eliminates unnecessary merge commits required by Git merge. Most importantly, the history of the changes made in the main repository remains linear and follows a clear path of changes. This allows us to navigate the changes easier when viewing the changes in a log or graph. Merge versus rebase. Okay, let's move on. So merge versus rebase. Although Git Rebase is an extremely useful tool to keep a Git repository clean and easy to follow, it doesn't mean that one should always stick to that command. When integrating code changes, let's go over the definitions of rebase and merge one more time. Git Rebase reapplies commits on top of another base branch. Git merge joins two or more development histories together, creating a new merge commit. In other words, Git merge preserves history as it happened, whereas rebase rewrites it. Generally, if one is dealing with numerous branches and the commit graph becomes really difficult to read, it can be useful to use rebase instead of merge. Since Git Rebase creates a linear history, it can be a lot easier to visualize the changes made and get a cleaner graph. Git merge, Git rebase. So in the end, each team will develop their preferred method of integrating changes and preserving history. Generally, it's useful to use merge whenever we want to add changes of a branch back into the base branch. And rebase is useful whenever we want to add changes of a base branch back to a branched out branch. Disadvantages of using rebase. As useful as Git Rebase can be, it doesn't come without risks. When using Git Rebase in our workflow, it's imperative to understand that rebase is a destructive operation and creates new commits, which can make it complicated to track the context of any changes made. One common rule when using rebase is to only use it locally. That is to say, once something has been pushed, then do not rebase it after that. Otherwise, things can get convoluted when rewriting history on a remote. Since we're rewriting history, we will also have to solve more commit conflicts. When we merge a branch, we only need to solve the conflicts once straight into the merge commit. However, when using rebase, we might end up having to solve the similar conflicts in previous commits that are being rewritten because rebase practically cherry picks each commit individually and attempts to merge it in. If a commit introduces a conflict, rebase will complain about it even if the conflict is fixed in a subsequent commit. In order to reduce the number of merge conflicts, it's suggested to rebase often and to also squash changes into one commit as much as possible. Moreover, make sure that the branch we're working on is not a shared branch. A shared branch meaning a branch that exists on a distant repository and the other people on our team could pull. Why should we avoid this? Well, remember that rebasing changes commit history. So if we share our commits publicly and others start additional work based on those commits, our trees are no longer in the sync after rebasing. As a golden rule, it's important to only use rebase on a local branch that we're working on individually. Conclusion, Git Rebase can be a very powerful tool when working with numerous people and branches. If used correctly, it allows everyone to view a very clean commit history and track what commits fixed, given defects, or whether or not a commit was included in a release. However, it's critical to understand how it works and the risks that come with it, since it's a destructive operation. If you've done so correctly, it can result in a very fluid and effective workflow. Git Rebase off-platform project. In the following project, you will practice the commands associated with Git Rebase.